Unpacking peak demand, societal rhythms of energy and travel. For the carbon emissions associated with electricity and transport, peaks are a problem. When electricity demand peaks, more carbon-intensive sources of power are switched on to top up the normal supply. Although more renewable sources of energy are now included in the mix, the timing of their supply does not often match the timing of peak demand. Quite simply, if the peak was lower, fewer power stations would be needed. There are ways of reducing the peak, like automatically switching off appliances or introducing tariffs that are much higher during peak hours. But what is it that makes this peakiness in the first place? Some peaks in electricity demand happen when lots of people are doing the same thing at the same time, like having a cup of tea after EastEnders. The main peak in electricity demand occurs between 5 and 8 p.m. on winter evenings, when it is dark and cold and when some people get home and start cooking dinner and others are still at work, all with the lights on. Peaks in travel are also strongly associated with the rhythm of the working day. They are concentrated in the morning because many people start work at 9 a.m, and in the evening when those same people head home. This makes public transport more viable, but it also produces congestion. Road and rail networks are often expanded in response, but this extra capacity may help encourage further travel, such as for off-peak leisure. In both cases, peaks in electricity demand and travel come about because practices are socially scheduled and organised around working hours, meal times and shared leisure activities. Practices also link together to form sequences, so commuting takes place before getting home and cooking happens before eating dinner, and this is why peaks and troughs in demand are not random. Some practices, like having lunch, matter for the timing and sequencing of others, like shopping and working. Meanwhile, traditions like a dedicated weekend structure the temporal rhythm of the week as a whole. There are variations in these temporal patterns. For example, cooking and eating, working and watching TV do not happen in exactly the same way each day, or over the seasons. On Friday evenings, people in the UK tend to watch less TV and also cook less compared to Mondays and Tuesdays. They also watch more TV in the winter than in the summer. But these sequences and patterns also change over time. In the UK in the 1950s and 60s, it was still common to return home from work at lunchtime. But lunchtime peaks, both in travel and in the energy used for cooking at home, have largely disappeared. Since peaks in electricity and travel demand are consequences of how social life is organised, they can't be shifted or reduced by act of will. Measures like peak time pricing or load management may help reduce consumption, but they do not fundamentally change the social and temporal organisation of daily life. Managing peak demand on a societal scale depends on understanding and intervening in how practices are sequenced and synchronised over the day, the week and the year. This might involve all sorts of adjustments, such as the timing of school days and holidays, moving from standard working hours to a number of socially shared working patterns, or adjusting the order or location of work and leisure activities. Many new possibilities come to light if we think about sequences and synchronisation of practices.